Hello, I'm Will. Welcome to ResearchPod. A warm, dry home is one of the basic comforts in life. A roof over your head, walls to keep you safe, and hopefully even nice neighbours in a pleasant part of town. In recent years, designing, building and maintaining these homes for the well-being of residents has come to take on an additional responsibility, to design and build homes for the well-being of the environment too. From the heavy machinery required from day one on a building site, through to the dust of demolition on the day that it's knocked down, it is possible to account for every tonne of carbon consumed and released over the length of a building's life cycle. Today I'm speaking with Dr. Stefanie Weidner from the engineering and design consultancy Werner Sobek about the company's mission in sustainable engineering, their case studies for successful design, and what the future of urban living might be. Dr. Weidner, hello.
Hello, Will. Nice meeting you digitally.
Well, thanks very much for finding the time to talk with us today and tell us all about the work that's going on at Werner Sobek. By way of introduction, could you tell myself and everyone listening at home a bit about your work, kind of what's led you to the position that you hold at the moment and some of the activities that come with the job?
Yes, hello everybody out there. My name is Stefanie. I am an architect by profession, so this is my university background. And after some years of studying, I decided, well, that's not enough. I need to learn a little bit more. So I ended up at the Institute for Lightweight Structures and Conceptual Design, which was headed during that time by Professor Werner Sobek. And Werner Sobek, he's a really big name in architecture and engineering. So I was very happy to be around him in the institute and to learn from him. And that's where I did my PhD in resource reduction in the urban environment. And after that, well, it somehow, one door opens, you go through. And this is what happened to me. I just jumped into the job at the office of Werner Sobek, where I became a director for sustainability strategies, and where I also get the chance now to direct the office of Werner Sobek in Copenhagen. I really like being around Danish architects. They're so talented and so many of them. So why we came here is more or less to not only bring something to the Danish market with our experience in structural engineering, facade engineering, and all of the expertise that we and also I gathered in terms of sustainability, but also to learn from the Danish market because they do stuff differently. And I really find that super interesting. And I'm looking forward to working with Danish architects and Scandinavian architects in the future. So my Danish skills are also improving day by day. And I really hope that we can get some projects here and work, as I said, in this very exciting market here. So we're going to bring all of our topics at Werner Sobek, sustainability, structure, and facade engineering with us here to Denmark.
What's the journey for you personally between the idea on paper and a building in real life?
Well, I was very lucky to get the chance to start with academia and then to have the possibility and the chance to go the next step into the practice. Because it would be fine to do a lot of research, but it wouldn't be any good for the environment, neither for the population or the public, if it never turned out to become part of a practice. So that's where I really want to work at, to get the information, to get the studies and the results from the research as soon as possible to the practice, because we need those new approaches. We are at the edge of times, you can say. It's the decision point if we're going left backwards and consuming as we've done for the last years, or turning right to the more future-proof sustainability road.
And how does that kind of connect with the Office of Werner Sobek in terms of a mission statement being future-facing and trying to embrace all of those new opportunities, new technologies, and a better future?
We have a very close relationship to the Institute still. Of course, Werner Sobek has now retired, but one of our board members, Lucio Blandini, he's still professor of the Institute for Lightweight Structures. And so we have a very close relationship to the research part. Well, actually, right now I'm on a conference in Aalborg in Denmark, and this is how close we are to research. We really want to be there and really want to take it over. And for statements at Werner Sobek, Werner Sobek himself, introduced already in the 90s the concept of 000. And 000 is what we are taking as the one goal that we are aiming at in all of our projects. Of course, in some projects you get closer to that zero, in some projects not as close as you wish for, but still 000 is where we're heading at. And just to give you a quick introduction to what 000 means is, well, 3 zeros. The first zero is zero energy. And by zero energy, we mean not just zero energy in general, but especially zero energy from fossil fuels and combustion. Because as soon as we don't burn anything, no emissions will be emitted for the energy. And so the sun actually gives us 10,000 times more energy than we need for all of our functions. So there is actually energy, and we don't have an energy problem, but, well, it needs to be done without combustion. And the second zero is zero emissions. And by zero emissions, of course, it's the operational emission, but also the emission that comes from the materials and from taking down buildings after their usage phase and from constructing buildings, from the transport of materials to the construction site. And thereby, we not only mean operational emissions, but also embodied emissions. And this is a very big issue right now. And the third and last zero is zero waste. And by zero waste, we also mean not just for the maintenance and stuff during the lifetime of a building, but especially on the construction site, by producing the materials for the building, and also afterwards, after a building's lifetime, by dismantling of the building and closing the loop in the end. Because if no resource is leaving the loop, then that's fine. And that's where we're heading at. So no waste, nothing can be lost, and nothing should leave the loop.
What are the current methods and restrictions of working in urban design? What is business as usual? Because obviously if we are aspiring to all of those zeros, then it means that we are not at those zeros at the moment.
Yes, unfortunately, we're not at those 3 zeros right now. Not yet, at least. The traditional way is currently that, well, developers or some building owners, whoever has the money, they decide they need some building. They need some built environment, some built space in the end. And then they come to an architect and tell them, okay, here, I need a building. Please design it for me. And then the design happens. And then at a certain stage, also some other disciplines like engineering, mechanical engineering, structural engineering come in and join the project. And if we're really lucky, then that's already happening on one table. So every discipline is talking to each other, which is also, it's not happening everywhere, but it's where we want to be. And in some projects, really, it does work. But then most of the plans that are being done in Germany, example, right now, are still two-dimensional. So the next step is really to make the digitalization and to get into 3D modeling, which means building information modeling, called BIM. And this is one essential part, I think, also in terms of sustainability, because as soon as you work together with all disciplines on this one model, digital model, you are much more efficient, and you will have a different kind of conversation, which is not happening on a 2D drawing at the moment. And then, of course, the production and the construction part is being done also by a different company, and they take over at some point, and they have their own agenda and in head. So this is what is used to be done, and that's not really quite where we want to be. We need this one sustainability manager who's really making sure that everyone is talking to each other, that everyone is on one table, really working on the same rope and pulling the project on the sustainability road and making sure that those goals are being followed through right to the end, also by construction, by producers, and by all parts, but all stakeholders that are involved. So this is where we're heading at. And I think, as I said, management of sustainability is one key word, and the other one is digitalization, information flow, work efficient, and make sure that everything connects and everything works together.
Well, as a case example of all of this hopefully working together from the top down and quite literally at the ground level, the work that's been going on in Hamburg, some of the buildings planning and operations that's been going there, even from the very earliest stages, at what point was sustainability brought into the brief? How much has that worked so far?
Well, Hamburg, especially the Hafen City in Hamburg, they have a really interesting concept. The Hafen City is a company that is responsible for a really big development area in Hamburg, in a very central area of Hamburg. They make sure that every project has not only a certification for sustainability, but also some overarching sustainability goals. And so those overarching goals, they need to be put into the contract with the developer that wants to get the plot. So I think this is a really good attempt of using sustainability not only as you need to do that because it's your responsibility for the next generation, but also to give them an incentive, by them I mean the developers, to really establish sustainability in their projects very early by giving them the benefit of a cheaper plot. It's an economic reason, but still, it's valid. It's very good. So by doing this, we join projects in this case very early because they need to put down their goals into the contract. And if they're in the contract, they need to follow it through. So I really like this principle that the Hafen City is working on there because, well, as I said, the incentive is there and the developers are getting aware, okay, certification is maybe not enough. We need to do a little bit more. We need to look at our embodied emissions. We need to do some recycling and need to take care of reducing resources in the project. And I really like that. So I hope that a lot of other municipalities will take up on this principle and use it.
Well, I think that covers some of the economics of sustainability and some of the psychology of it as well. But to talk directly about the chemistry of sustainability, we've mentioned embodied emissions a couple of times and where those come into the developmental cycle of building a building, its life cycle, and afterwards. What specifically are the emissions that are involved? Because the most famous emission out there that people might be aware of listening is carbon dioxide. We think of generators making carbon dioxide and cars as well. Are there any other less famous emissions that we've got to be wary of?
The Kyoto Protocol has set 6 greenhouse gases, and all of those can cause emissions. There are several other gases that do cause emissions, but those 6 were primarily set in the Kyoto Protocol. And the reason why everybody focuses on CO2 and all of those other emissions are being calculated in CO2 equivalent, the reason is that CO2 lasts in the atmosphere for a very long time, like 800, 900, or 1,000 years. And that's the reason why CO2 is, or why it's possible to calculate budgets with CO2. Because what we emit now, it will stay there for the rest of our lifetime, of the lifetime of the following generation. And that's why everybody uses CO2 as the primary greenhouse gas. And by the way, in Germany, for example, we have 88% of all greenhouse gas emissions is CO2. So it does really weigh a lot. But that's the history around it. And this is why IPCC, for example, they always use CO2 as the number or as the element for the budget and for the global warming potential analysis.
And you mentioned earlier that there was the different life cycle stages of the building from beginning to end and kind of even the afterlife of it, of reusing the material. So in terms of where all those resources are being used, reused, how do we look at the life cycle of a building and say this is where these emissions are happening, this is where those emissions are happening? And is there any kind of a vulnerable point where the most immediate change can happen?
Well, if you think of a construction of a building, then there are a lot of different life cycle stages. That's how the term in LCA really is called. There are a lot of life cycle stages, from the production to the usage phase to the deconstruction and then to a potential recycling or afterlife. And what happens when you build a building is that everything that's done in the phase A, which is the first one, all of those emissions are being emitted. And that happens before the first tenant really opens the door and steps into the building. So these are crucial to address because, as I said, they happen right away. And what is included in there is, let's stick to concrete, for example. I have A1. That's where I get the sand. I get the cement and all of those elements together. They are either somewhere on a site in nature or they come from a recycling element. But that's where I get them. Then A2 means the transport. I take the sand and transport it to the concrete facility, concrete production site, let's say. And there we have A3 happening. So concrete is being mixed with, sand, water, cement. And during that time, not just you need a lot of energy. And right now, most of those energy comes from fossil fuels, but also you get some process-related emissions. And this is a little bit tricky because that's quite into chemistry, especially the cement. Well, it used to be some kind of, let's say, stone. And during the lifetime of the stone, during the creation, it has taken up carbon. And when you heat that stone, when you heat that brick, in order to get cement out of it, you need to heat it up quite a lot, over 1,000 degrees. And by doing that, the embedded carbon gets free again. So there's nothing you can do about it. You could get the heating with green energy, no emissions, but still the carbon leaves the brick. And this means, the Portland element. And this means that this process-related emissions, they cannot be spared at the moment. And they happen in A3 too. So this is from cradle to gate, we say, because gate means it's the gateway where you fill up the truck and you send it to the construction site. And from cradle to gate, we have a lot of emissions happening. And then A4 is the transport distance between the concrete factory and the construction site. And then A5 means, you need some material, some cranes or whatever to get the concrete in the building and to build it. So long story short, A1 to A5, this is happening right away. These are the emissions we need to consider right away. And we always need to consider what happens in the future can be changed. I mean, we don't know how the processes are in 20, 30, 50, 60 years of time. So we can just project them, but they're a little bit unsure. But what we can look at is to make the lifetime of this element, maybe concrete, maybe just carpentry or whatever, to make the lifetime of this product as long as possible. Because that means that the other things can be postponed to as far away as possible date. And then the emissions just happen, or maybe just don't happen anymore, because we have a totally different system that will allow us to just preserve all of the material and don't emit anything at all. So yes, that's it. I hope it wasn't clear, but feel free to ask some more.
Well, once that has all gone into the construction of the framework of the building, and you mentioned that there's then everything that goes into the building before the people arrive, the lighting, the heating, the ducting, the electric cables. With all of that in mind, how can one measure the diet, I suppose, of the building, the energy consumption?
Well, in terms of operational energy, or operational emissions rather, there are several publications that show that for the time being, or for newly constructed buildings, it's probably more than 50% that end up in the embodied emission calculation, and just the rest, that would be operational emissions. Operational energy, they happen bit by bit. So every year you have a little bit of emission for the operation, and it just adds on after 50 years to be equivalent in sum to the embodied emissions. But what we forget is that the time frame really matters, because, as I said, those embodied emissions, they happen right away. And from that point on, they are in the atmosphere and they can do damage there and they can do harm and all of that. Whereas the slowly accumulated operational emissions, they don't do that much harm right away. The other thing, you need to look at the building as it is. And that's what I did in my doctoral thesis, actually. And I investigated different residential building typologies and took a look at how single-family houses, multi-family houses, like 4- and 6-story buildings, and high-rises, how they are being constructed. And I also compared different urban densities to each other. And what I found out, probably everyone expected the results, but it was the first time, as far as I know, that somebody actually proved it, is that single family houses are really, really bad. And the best way to build efficiently is to have a 6-story multifamily house. And this is because the floor area of efficiency of single family houses and also of high rises, I must say, is quite bad. In terms of single family house, you have a lot of construction floor area because the walls are just as big for a 4 and 6-story building as they are for a 2-story building. Then you cannot share any circulation area with other tenants of other apartments. Then you don't share any technical floor area with anybody else. So it's all just that one building that needs all of that. And then single family houses are also quite heavy. Per square meter, it's more than 2 tons that single family houses use up. And for the multifamily houses, instead, we are down to, I think it's 1.4, 1.5 ton per square meter. So it's quite lighter and it's just more efficient in the floor area. I do think that high rises could be one solution, especially for very dense areas and very dense urban cities. And that's also where the population growth is happening over the next years in those already quite dense cities. So floor area or buildable area is very rare. That's why high rises become very popular. So in terms of getting high rises up to a sustainable level also means to increase the floor area efficiency, to maybe think of vertical transport systems, to decrease the amount of the core, just to have a bigger usable area. On the other hand, what also was quite interesting to see is if you take in the infrastructure you need to get to those buildings and compare it on an urban scale, then you end up with the information or the knowledge that the denser you build, the better, because you can just divide up the space by so many users. And also here, very spread out solutions with single family houses every once in a while. They use up a lot of infrastructure as well. And this is what we cannot forget.
Well, to go to Hamburg as the Half City project, putting as many of these good ideas into practice as possible, from the construction and the embodied emissions to planning around a usable space for as many people as efficiently and effectively as possible. Have there been any challenges in terms of deploying all of those solutions, and how are things looking at this point in time whilst the project is still ongoing?
There are some difficulties, I must say. One thing is how to get all of the plans you have and the ideas you have into realization, because obviously, I mean, it is reasonable, but obviously money plays a big role. And for the time being, a lot of people and investors mainly look at the investment costs, so for the first construction, and don't expand their view over the whole lifetime. Because, well, sometimes material is more expensive in buying it for the first time, but in the end, over a lifetime of a building, you might not need to exchange it that often. So in the end, it wouldn't be that much more expensive, actually. But so this is a little bit tricky to get the swift of mindset into our client's head. And the other thing is that there's also a scarcity of resources right now, and also of, for example, different concrete mixtures, timber products. All of that is really rare and all of these components have become very expensive over the last year, especially. And of course, the last half year are also paid its toll for that. And so there's quite an uncertainty that we feel. And well, in one project, we'd like to do some reusage of bricks, but it's super difficult to find some kind of storage hole or something in a city like Hamburg. So if Hamburg really wants to push on those topics, then I think we need to help developers here and need to tell them, okay, we've got Hamburg as a city, I'm speaking of now. We've got this area over there. We can do some temporary structure to just have some storage there. It's an intermediate storage for you to to store the bricks there and not having them transported once through the nation just because there is no space here. So this will be something I'm wishing for, and I'm hoping for, that this will pick up on pace over the next years. And for that, we need to raise awareness, and we need to do talks like this.
Is there anything that you see from kind of the cutting edge of technology that can fix any of the problems that you've encountered along the way? Are there any new formulations for concrete, any new deployments for, I don't know, electric infrastructure or heating? What is a far future, perhaps, an imagined future for how things could be different, be better, or be an interesting way to find out?
Yeah, interesting question. I do think that maybe robotics play a bigger role in the future, even on construction sites, because while manpower is rare, manpower is expensive, and at least in Germany, we don't have enough people to really do the work and do the work properly. Maybe this could be one thing to say in future we'd see some more robots on construction sites. And then we've been in touch with a lot of concrete and cement industry people, and we frequently catch up with them and to ask, what are you doing? What are your plans? Where are you heading? And it is super interesting to see what they want to do and where they're actually moving to. And for them, it's not very easy to do some major changes. And it's just, more or less baby steps working forward. They are now focusing on substituting those Portland elements for the cement because, as I said, the emissions here are really hard to be working around with. And so that's one focus, to substitute it, to also change processes in order to get less fossil energy and more so-called renewable energy into the process, and to just actively reduce emissions there. It is a slow process, I say. And then you always have regulations and laws that make it even a slower process. Same thing actually with the steel industry. We do see them also working on different systems, how to melt steel, how to use also for construction steel, not only reinforcement steel, more recycled material. Yeah, so there are some progresses going on. We are always aware of that. And as I said, working with the industry on that to be informed. But it is a long way. And same with timber, by the way. It's a super nice material. I really like timber where it really makes sense in a building. But also here in Germany, it's forbidden to reuse timber elements. And this is something that doesn't make sense because I don't want to burn or combust the timber after usage. This is just against circularity. I would really like to use it further as a material over the next decades to come, even after being taken out of the primary usage place. So to cut it off, it's been some things are going on. I hope for more to come. We need some innovations on different materials. We need to work with more different materials, not just reinforced concrete and timber. Maybe there could be some fabrics in, maybe some 3D printing, different technologies. And I'm really looking forward to working with them in the future.
Well, an alternative perspective on the future, rather than new technology and all of these ways to do more and do better, would be that there might be just a limit to growth and development. There's only so much that can go out of one resource location, out of one resource source, and into a transformed location. Like you say, getting sand from one place to another, that with every building that is torn down, you can save as many bricks as you can try to, but there will be some destruction, there will be some loss that you cannot 100% recycle, you cannot 100% supply everything infinitely forever. Is that anything that you personally or like the industry is trying to face up to? Is there only so much that we can do?
Yeah, I think we really need to set as a limit and a budget, not only in CO2 wise, but also in resource consumption wise. And this would lead also necessarily to more innovation, because then you just need to work around with what you've got. And especially for those countries like we are living in the industrial world, we actually don't need to build much more because, well, over the next 100 years, our population won't really grow. So for everything we've got, there should be a further usage and a longer lifetime period. And that's what I think the construction industry will necessarily focus on a lot over the next decades. And that is on reusing existing building material structures. So renovation, retrofitting, and transformation are the buzzwords of the next generation, because we've got a lot of material already built somewhere. Maybe it's not exactly where we want it to be, but I mean, due to COVID, we've got a really big push in terms of digitalization. So we're not sitting together, but it's working. And just not to have those building elements where you want them to be doesn't mean that you cannot use them at all. So either you use the components as they are and take them as they are to a different plot, or you really get your usage to the plot and work with what you find there. That's one of the first things that we look at. Is there something, when we do the consulting, is there something that we can use further? Do we have an existing building that maybe needs some transformation and then could be very well on keeping resources and also on reducing emissions?
Is there anything that people listening to this, if they are in a professional position, like a planner or a builder, what can they know, having listened to this podcast, that they might not have known before they listened? And if there is any difference to what people in the public would take away from that, what is someone who isn't in research but does want to know about the future of building, what could they learn from this as well?
Well, I hope that our conversation will help you understand how important it is to look at projects individually, to always decide very early in the project to confront sustainability and to not only confront it, but also to take it to the heart of the project. Because I really think this is very necessary for us to at least somehow make it to the 2-degree Paris Agreement. I'm not speaking about 1.5 because I really don't think this is possible, but 2 degree is not too far away. And the building environment, it plays such a big role. When you calculate the emission that are being caused just by the operation and the construction of our buildings and also of the infrastructure, it can add up to over 50% of the global emissions. So it is necessary to know that, and it is necessary to work on this, to first do reduction, reduce the amount of new construction, reduce the amount of built area, and also maybe look at yourself, reduce the amount of floor area you need at home or you need at your office. And then if you build, then build wisely and use not only less material, but also use recycled material, reused material, and material that can be integrated into the system again and is not being produced with too many embodied emissions. And then I think we're somehow on a good way, but this needs to be transported into everybody's mind. And that's why I'm always jumping, or not always, obviously I'm also working, but I'm also quite a lot jumping into presentations and panel discussions just to make people aware of that and to pinpoint that there are solutions. You need to connect, you need to network, you need to be in touch with all stakeholders, and not only developers, but also architects, politicians, industry. So all of these people need to be taken on board, and then off you go to the sustainability road.
If there's any way that people want to be in contact, if they want to head to, I don't know, a personal website or the Werner Sobek site, I understand that you have a podcast as well, or any upcoming publications that they might want to read that we can have all the links to in the description.
Yeah, actually, there will be some publications coming up. As I said, I'm just at a conference, which is also combined with a paper. And then we have several papers that can be downloaded on our website, which is www.wernersobek.com. And yes, please feel free to reach out if you like this podcast and if you like the information I gave you. There is a lot more that I can tell you. So I'd be super interested in doing conversations and diverse conversations, I call it, because there's not just one solution. We need to look left and right and up and down and have the broader picture in view. So yes, please feel free to reach out. And you can also find me on LinkedIn. So many ways to connect.